Hi, welcome to this episode of the Data Beat. My name is Puneet Sachdeva, and today I will talk about AlloyDB, which has been recently introduced by Google at its annual technology conference called Google I/O. As the host of the Data Beat, my aim is to bring the latest from the world of data analytics. Like always, it's a good idea to like the video, subscribe to the channel, and click the bell icon to get notified about the new shows. Well, I like connecting the dots, and I feel besides gaining skills and knowledge on the latest and greatest technologies, I believe it is equally important to know how it all started and what decisions were made on the way. AlloyDB is a new fully managed PostgreSQL compatible database service by Google, which is claimed to be 2 times faster compared to AWS Aurora PostgreSQL and 4 times faster compared to standard PostgreSQL. During the technology conference, Google unveiled these benchmarks and taken the whole community by surprise. You must be thinking, after all, it is PostgreSQL under the hood. So what makes it so fast compared to the competition? Google worked on the PostgreSQL kernel and modified it to make full use of the underlying infrastructure and the database architecture. Not only this, under the hood, AlloyDB makes use of multiple proven performance techniques and makes them available to all its users as a managed service. So you do not have to worry about provisioning nodes, setting up your own database, making connectivity, and all those things. These improvements allow it to scale linearly to over 64 virtual cores on the analytical side. AlloyDB's engineering team made use of machine learning based optimizations as well. And I'll try to cover more on it, shortly. Diving deeper, talking a bit about the PostgreSQL architecture, which majorly includes, 4 subsystems. The first one is the storage manager. The role of the storage manager is to organize the data files, also the write-ahead logs, and organize other logs and archive files as well. The second subsystem is the query processor. It basically manages the connections, parses the query, plans and executes it, and also interacts with the storage manager to read and write the data. As well as it interacts with a third subsystem called the process manager, which is majorly the client. The third subsystem is the utility process, which performs the enabling functions of checkpointing, log collection, archiving, other activities such as stat collection and compression. Now, as per the details shared by Google at the event, the storage system has been optimized to work with Google Distributed File System or GDFS. However, that is not the only change. To have fast and predictable performance, industry practices of caching and using the columnar data format have been applied as well. Now, you might say, what's so new about it? Well, Google has made it integrated in a way that makes it so powerful. Let's understand briefly how it works. In any data management system, I/O has always been the most costly operation. To tackle this, Google included what they call as the ultra-fast cache. So whenever there is a read operation performed, the data is first looked up in the cache. If it is available, then the latest version is read from the cache, or else it's read from the AlloyDB storage, while simultaneously updating the cache as well for future reads. Data is read from and written to this cache and subsequently the AlloyDB storage in a row format. Row format, you must be surprised because just a while ago I mentioned about utilizing the columnar format. Yes, I did mention about columnar, but this transformation of row format to columnar format happens on the fly. It is performed within the DRAM and Google terms it as AI/ML driven auto columnarization. It will be interesting to know how this AI/ML driven columnarization works. Maybe I'll try to gather more details and cover for you in the later episodes. Now, why this conversion is required? And why there is a need to use both row and columnar formats? As per my understanding, row format has always been the right format for you to read data completely, in a single read and take everything from the storage. So row format is chosen for caching and storage mainly to ensure that the entire row is read as it is, because anyways it is going to get converted to a columnar format. So having a row format at the storage layer and the caching layer actually helps. The overhead caused by the row format, both read and write, was to some extent optimized by the ultra fast cache, which is actually additional cache layer outside of the DRAM. And the main reason to use columnar format is mainly to optimize the queries, as it allows you to get the specific columns only which are required by the query. Well, that was what I could gather from the public domain on AlloyDB. Hopefully in the future episodes, I'll try to gather more details around it. Having said that, do you know how it all started? It all started with a database called Ingress database, which was a proprietary SQL database. It was created by a company called Relational Technology Inc. Relational Technology Inc. later became Actian Corporation, which besides Ingress and other tools, researched and developed the fastest object database as well. In 2018, Actian Corporation was acquired by HCL Technologies. Recently, they introduced the Actian Avalanche Cloud Data Warehouse. Coming back to Ingress, a fork of Ingress DB was open sourced and is popularly called as PostgreSQL. Later, AWS used the PostgreSQL to create Aurora, and now Google has taken it to next level with the AlloyDB. Well, we come to the end of this episode wherein we talked about AlloyDB, how it works under the hood. Also, we talked briefly about the early days of Ingress and how it became the PostgreSQL. Feel free to reach out to me through your comments. I'm eager to learn from your experience and share my experience with you as well. My intent is to simplify the concepts and bring them to you. If this helped you to build some understanding, then I think it's a good idea to like the video, subscribe to the channel, and share it on LinkedIn or where your peer group is. So until we meet next time, keep the beat flowing. Thank you.